Now we can actually view these generations using the VisualVM tool that we saw, again, I think it was a couple of chapters ago. So let's load that up and we can have a look at what it tells us about the structure of our heap. So I've started up VisualVM and I've got Eclipse running on my machine. That's actually the only active Java process right now. I'm not running any Java applications. So I think what we could do is connect to the Eclipse IDE and have a look at that. So I hope you're following along with me. We'll open up Eclipse and we'll start in the Monitor tab. And notice that, I'll just get rid of these other graphs, certainly as far as the heap is concerned, Eclipse is a well-performing application. It's using, it looks like about 200 megabytes of the heap at the moment, but this is not growing or shrinking massively, so it doesn't look like there's a huge amount of garbage collection going on. But there is a Perform GC button up here, which should force a garbage collection, so let's click on it to see what happens. And well, as you can see, the amount of memory has decreased. A garbage collection did happen. So that's showing us the amount of memory. It's showing us the heap in total. But let's see how to break this down into the generations. Well, to do that, we need to install a plugin. So to install the plugin, we want to go to the Tools menu and choose Plugins. And then go to Available Plugins, and you want to select the one called Visual GC, this one here. Just click on the tick box and choose Install. We'll click on Next, and we need to accept the terms of the license agreements. I'll leave you to read those. Choose Install again. Give that a moment to run. That's now finished. We can click on Finish and Close, and we need to close and reopen our connection. And we'll see that there's now an additional tab called Visual GC. Now, I'm running, again, Java 8. If you're running Java 11, actually what you'll see on this tab looks a little bit different, and the behavior that you'll see, again, is going to be different. Don't worry if that's the case. I will be explaining that in the next chapter. For now, we're just focusing on the Java 8 behavior because there was an improvement in Java 9, which, as I said, I'll go into in the next chapter. So what we've got then is two main sections on this screen. The left-hand side shows us the amount of metaspace, old generation and the young generation split into Eden and our two survivor spaces. And on the right, we can see how much of these spaces are being used over time. The solid blocks represent used objects. So we can see that our Eden space is very slowly growing, but nothing that exciting has happened, which is exactly what we'd expect because, of course, Eclipse is a well-performing application. Now I'd like Eclipse to do some work, so I'm going to press the play button and run the application that we were looking at in the last chapter. When I do that, what we're monitoring here, of course, is Eclipse's heap, not our running applications heap, but we should hopefully see enough new objects being created that a garbage collection will happen, a minor collection, and we'll see the objects move from Survivor 1 to Survivor 0. And just as we've been speaking, by pure luck, actually that just happened. So we saw then that Survivor 1 emptied, the objects that managed to survive moved into Survivor 0. It didn't look like any objects made it into the old generation in that particular minor collection, and our Eden space emptied down. I will click the play button now to run that application, and what we'll hopefully see is the amount of objects in the Eden space will suddenly start to grow quite significantly. We can see that's happening there. I think I'll stop my application and let's do a build. That was running for a few seconds, and off camera what we can see is another garbage collection happened, and this time the two survivor spaces were actually emptied because the build process cleared everything down, and in fact even some of the old generation got emptied out as well in that last garbage collection. So let's connect to our own applications and we'll have a look and see what happens with those. I'm going to connect to the Soft Leaks application. I'm just going to start that running first of all and make sure it's running in the efficient way. So I've started that off camera. It's been running for a little while. As you can see, the number of customers in the queue is staying quite low. So I've got the right version of this working. Let's go and see this application in JVisualVM and see what the heap looks like. So we'll connect to Customer Harness this time and go to the Visual GC tag. And I'm just going to leave that to run for a moment or two off camera, and then we'll see what we're seeing here and try and understand what's going on. Okay, well, I think that's been running for long enough. This application, if you remember, is creating a huge number of customers which are immediately being destroyed. So there's very little that is surviving. And I hope that you can see that's what these graphs are showing us. We can see that the Eden space is filling up very, very quickly, and it looks like there's almost a continuous garbage collection happening in the Eden space. This graph here is showing us the garbage collections, and they're a very frequent occurrence. But every time that garbage collection happens, well, almost all the Eden space is garbage. There's very little that is being kept and moved into the survivor spaces. And in fact, you can see these alternating survivor spaces now, the overall size of what's in there is certainly not growing. Very occasionally something gets moved into the old generation, but that's definitely not growing in any kind of fast pace, so we can be comfortable that this application is performing well. Yes, there's lots of minor garbage collections, but they're fine. There's no sign of any major garbage collection needing to happen, so this looks to be an efficiently performing application.